Okay, in this particular problem here, this is 5.3 and this is problem number 5. Okay, as you see, this is the function. Powers are the same, the lead coefficients are both 1, so that means your horizontal asymptote is going to be 1. But we'll look at that again. There are your steps. 5.3, number 5. First thing you need to do is to factor the numerator and the denominator. Of course, notice this denominator is really x minus 1 squared. So it's a little bit different in that it's a square. X does not equal 1. Have to leave it out of the denominator. And one of these reduces, but not both of them. So you end up with x minus 9 over x minus 1, but you will have a vertical asymptote at x minus 1. Because this is kind of what you're looking at this point. Horizontal asymptote, even powers, lead coefficients 1, 1 divided by 1 is 1, and there is no oblique asymptote. So then it does ask about the intercepts in this particular problem. This problem does a good bit. Your intercept, your x-intercept is at 9. When does that happen? That happened when the numerator would be equal to 0. What was left, when that x minus 9 equals 0, that would be your x-intercept. Your y-intercept is what happens when you plug in 0 for x. 0 for x leaves you with negative 9 over negative 1, which is 9. So those are the 2 points. Your x-intercept is at 9. It's referring to that point. Y-intercept 9, referring to that point. Sometimes it asks for just values, and sometimes it asks for ordered pairs. If it asks for ordered pairs, be sure you give it ordered pairs. If it doesn't ask for ordered pairs, be sure you answer it correctly. The graph will cross the x-axis at x equals 9, and the graph will, the factors are the powers that cause it to cross and so forth. The graph will not just touch at 9, it actually crosses there. The graph approaches infinity on one side of that asymptote, and it approaches negative infinity on the other side of the asymptote. We'll notice a little bit more about that when we look at the graph at the bottom. There is no point at which the graph of f intersects the horizontal and oblique asymptote. Some of these are just answering the questions that are on the worksheet. The graph of f is above the x-axis on these intervals, and it's below the x-axis on that interval. So, look at your graph here. This is original there. This is your x-intercept, that's your y-intercept. These are your 2 asymptotes. Notice at 1, the original is undefined. You've got an asymptote because it didn't cancel completely, so you wouldn't have a hole. When it asks for what it does at this vertical asymptote, as it approaches, it's coming in this way, it's approaching positive infinity. When it comes in this way, this graph is approaching negative infinity. The function value is your y value. That's what's going on there. When is this above the x-axis? In other words, when does it have positive values? It's above the x-axis from negative infinity all the way. Where was this? At 1. And then it's above the x-axis again from 1 to infinity. The only area that was below is this piece right here, and that is from 1 to 9. From 1 to 9, it's below. From 9 to infinity, it's above.